Statistics Lesson 7, Confidence Intervals and Margin of Error. So this is should be a fairly easy lesson, just some terminology. And we're going to learn about confidence intervals. So this lesson, we interpret statistical data using confidence intervals, confidence levels, and margin of error. So we're going to learn about 3 different terms. Note that the focus will be on the interpretation of data rather than the actual calculations. So it's more interpreting what we have than actually calculating. So in our previous work involving the normal distribution, we have determined means and standard deviations from populations. Consider the question, what is the mean height of all the students in your school? We can determine the correct answer by measuring the height of every single student in the school. The result would be the population mean. In practice, in reality, the population is very large, and so if I need to get the average height of, say, the whole world, or maybe the whole school, we want to take a sample mean. But then how confident will we be that the sample mean and the population mean are the same? So when we take data from a sample and calculate the sample mean, we can never be 100% sure, confident. Not 100%. The sample mean is going to be the same as the population mean. In fact, it would be a rare occurrence for the sample mean to be exactly the same as the actual population mean. The best we can hope for is that the sample mean will be close to the population mean. So we can determine a range of values around the sample mean in which we can be reasonably confident that the population mean lies. So if we have a range of value, we can be confident that it lies within that range. So in a sample mean, for the heights of students is 67.5 inches, we cannot be sure that the population mean is 67.5. But we can be reasonably confident that the mean height of all the students in school lies between 65 and 70 inches. We'd be very confident that it lies between 63 and 72 inches. So the range of values from 65 to 70 is called an interval. So when it's a range of values, that's called an interval. The interval can be written as 67.5 plus or minus 2.5 inches. The 2.5 inches is what we call the margin of error. The range values from 63 to 72 inches is also called an interval. The margin of error is, so what would be the margin error? So your question would be then, what's halfway between 63 and 72? Well, what's the difference between 63 and 72? 72 minus 63 gives us 9. So if I grab my calculator, sorry, 1 second. There we go. So if I know that my range is from 72 to 63, and then that they're 9 apart, then halfway will be 4.5 apart. So 63 plus 4.5 gives you 67.5. And then, so that would be 4.5 to that direction and 4.5 to that direction. And so the error in this case, the margin of error, would be plus or minus 4.5 inches. We'd be more confident that the population lies between 63 and 72 inches than the interval 65 and 70, right? The larger the range, the more confident we're going to get with our data. The level of confidence that we have, the level of confidence that we have that the population mean lies in a particular interval is called the confidence level. And it is usually given as a percentage. The interval known is as a confidence interval. So just to review, if I was given something like this, 63% plus or minus, let's say 2.5%, okay? So this whole thing is what we call a confidence interval. The confidence interval can be written this way. We could also write it as what 2 values it lies behind. So between. So 63. So if I subtract 2.5%, I get 60.5%. And if I add 2.5%, that's going to give me 65.5%. So you can also write the confidence interval as 60.5 to 65.5%. The 2.5% here is what we call the margin of error. The margin of error. Okay, there's one more thing we're going to talk about is the confidence level, and we'll talk about that in a second. So turn to the next page. So consider the following question. What percent of Canadian voters would vote for the Conservative Party? It is not practical to survey the whole population of Canada voters, so a sample is taken. This is how they're done. A polling organization conducts an opinion poll whose aim is to determine the percentage of Canadian voters who would vote for the Conservative Party. They released the following statement. In this poll, 38% of Canadian voters said they would vote for the Conservative Party. The results are accurate to within 3.5 percent points 19 times out of 20. So in this statement, the margin of error would be the 3.5 percent points. Okay, so that would be the margin of error, the plus or minus 3.5% error. That would be your margin error. It's the difference between the sample estimate. So that would be your margin error. The confidence interval, you could say, is the 38% plus or minus 3.5%, or you could say the range. So we take the 38% and we're going to subtract the error. So 38% minus 3.5% gives you 34.5%. And then we take the 38 and we add the error, 41.5%. So we're confident, it says 19 times out of 20, that people will vote Conservative. The percent of people who vote Conservative would be between 34.5% to 41.5%. This last part is what we call the confidence level. So how confident we are in our data. Now you don't have to learn how to calculate that. What you just need to know is be able to interpret it. Say that is the confidence level. So 19 times out of 20, if we divide 19 by 20, that gives you 0.95 or 95%. And so there's a 95% confidence level. So if this is a bell curve, we know that our mean would lie between 34.5 and 41.5, and that would give us 95% of the data. So that's how confident we're in, that our mean is in between those two values. So let's look at an example. In order to determine the mean mass of a golf ball produced at a factory, sampling is done, and the following statement is made by the company. The mean mass of the golf ball produced at our factory is 45.6 grams plus or minus 0.3 grams. The results are accurate 19 times out of 20. So your confidence level is the 19 times out of 20. So we just turn that into a percentage. 19 divided by 20, so with your calculator, that's our confidence level. Times 100 is 95%. So that equals 95%. That's our confidence level. The confidence interval is this guy. We want to actually get the range of data. So how do we turn this 95.6 grams plus or minus 0.3 grams? We take our 45.6, we're going to minus the 0.3 to get our lower end. So 45.3 grams to, we take our 45.6 and we're now going to add the 0.3. And so the interval is from 45.3 to 45.9 grams. That would be your interval. The margin error is the last part, where our error is plus or minus 0.3 grams. Okay, so just all you have to do from this lesson is be able to pull out what different things are called. Is it likely that the mean mass of the golf balls produced in this factory is 45.1 grams? Explain. Well, look at our range. Is 45.1 grams within that range of 45.3 to 45.9? The answer is no. No. Since there is only a 95% chance that the mean mass could be outside the confidence interval level. a 5% chance. No, since there is only a 5% chance the mean mass would lie outside our confidence interval. Is it possible that the mean mass of the golf ball produced at this factory is 45.1 grams? So looking at our range, is that within our range of 45.3 to 45.9? Is it possible that the mean mass of golf balls produced at this factory is 40? Is it possible? So notice the difference between is it likely in D, between is it possibly? Is it possible? Yes, it's possible, right? There's a 5% chance. So it is possible. So it's outside our range. Yes, it's possible. Is it probable? No. Okay, so next page. So a lot of times these type of, you'll see a lot of stats, like papers or any type of medical paper. You might see something like this, advertisements on TV, or even polling. So here's some more polling information. 2011 Canadian federal election took place on May 2nd, 2011. A large number of opinion polls were conducted in the days leading up to the election. So here's a whole bunch of information. So there's different types of polls that were, so here's 4 different polls: the Harris Decima, the Angus Reid, the Nanos Research, and then ECOS Research. And there's different polls. So they polled whether they'd vote, the people would vote Conservative, Liberal, NDP, the Bloc, and then the Green Party, and then the margin of error for this poll. So look at the columns for the number in sample and margin of error. How does the sample size affect the margin of error? So notice that. Let's take a look at something here. So if we look, there's 1,011 people in the sample. Margin of error was 3.1. Okay, this sample had 2,197. And now, so I'm just going to write these down actually, because it might be easier to see when we write them down. So when our sample was 1,011, we got an error of 3.1%. When our sample was 2,197, my error was 2.2%, plus or minus. Okay, when our 1,048, my error became 3 plus or minus 3.0%. And then 2,690, my error was plus or minus 1.8%. The larger the sample size, what do you notice about the error? So the larger the sample, the smaller the error. Larger the sample, the smaller the error. And why is that? Well, the larger sample we take, the more like the population it's going to be like. So if I just sampled our class, there's a huge error in that. If I sample all of Edmonton, it's going to be a smaller margin of an error because it's be closer to the actual population of Canada. So for each polling firm, calculate the 95% confidence interval for the percent of Canadian voters who would vote for the New Democratic Party, and complete the table. How does sample size affect the range values in the confidence interval? Okay, so Harris Decima, we're looking at Harris Decima, and we're just looking at the NDP. So this part, and we need its margin of error because we're making the interval. So the Harris Decima is 30% plus or minus 3%. 30% plus or minus 3.1%. So we want to create the range. So we grab our calculator. So we're at 30. So we first need to subtract the 3.1%. So, subtract, and then we add. So 30 minus 3.1 and 30 plus 3.1. So our range is between 26.9% and 33.1%. Angus Reid was 33% plus or minus 2.2%. Plus or minus 2.2%. So again, to get the low value, we want the range. It's going to lie somewhere between. So 33 minus 2.2 is 30.8% minus, and now 33 plus 2.2 gives you 35.2%. Nanos, now we're doing 30.6 plus or minus 3%. Plus or minus 3%. So to get our low value, we take the 30.6 minus the 3, gives you 27.6. So between 27.6 and 30.6 plus 3 gives you 33.6% of the population. In this survey, they thought between this range of the population will vote New Democratic. And then the ECOS. So ECOS, the last one, the range is that we have an interval of 31.2% plus or minus 1.8. So to get our low value, 31.2 minus 1.8. 29.4%, 2, then we take the 31.2 and we want to add the 1.8. So there's my interval to 33. Okay, so there's my range. So for each polling firm, calculate the 95% confidence interval for the percent of Canadian voters who would vote for the Conservative Party and complete the table below. So basically we have we already did the confidence interval for NDP. So I'm just going to write this down. We did this on the other page for the NDP. So write it filling in what we already just calculated. Okay. So these are the 4 different survey companies again. So now we're looking at the Conservative. So now this time, go back to this chart, we want to look at the Conservative, and again, here's our margin of error. So to get our first chart for the first survey, here is Decima. We take 35 and we subtract our error, and then we take 35 and add our error. So the first range, to the next page, would be 31.9% to 38.1%. Write that down. 31.9 to 38.9, 38.1%. Okay, so Angus Reid on the previous page. Now we're going to take the 37% with our error plus or minus 2. So 37 minus 2.2, 37 plus 2.2. So now our range becomes between 34.8 and 39.2. So that was 34.8, 39.2. Okay, nanos. Now we're looking at 37 and our error of 3. So 37% minus 3 and 37 plus 3. So this one's easy. Between 34 and 40% will vote Conservative. 34% and 40%, I believe it was. And last, we have ECOS. And ECOS is, wrong way. So 33.9 minus the 1.8% error, and then 33.9 plus the 1.8% error. So 32.1 to 35.7. Okay, so in which of the polling firms is there no overlap of percentage in the confidence interval? So what it's saying here is, if I were to put this on, here's 0 to 100%. So in the first survey, Harris Decima, we go from 31.9 to 38, wherever that is. So 31.9 all the way to 38%, 38.1%. So that's the Harris survey. That was for Harris for conservative. So green conservative, I'm doing green conservative. Oops, that's not green. Green conservative. In red is NDP. So NDP starts at 26.9, somewhere over here. And then it goes all the way to 33.1, so somewhere over here. 33.1%. So notice how there's an overlap there. So there's a chance. So although the ranges, the numbers are higher for conservative, there is a chance that if you look at the largest number for NDP and the smallest number for conservative, there is a chance that NDP could get more votes, 33.1%, than conservative, that's 31.1. And so there is an overlap there. So it says, in which of the polling firms is there no overlap? So there is an overlap in this one. Let's check it, Angus Reid, 34.8 to 39.2. So if I redo that line I have above here, helps if you have two different colors. So I'm going to do green for conservative. So 34.8 to 39.2. Okay, now the other one is 30.8. So over here, it's a little bit exaggerated. 30.8 to 35.7. That is larger than the 34.8. So there's an overlap here. Okay, let's try again for the next guy. Is there any overlap? So there's a chance again with the second survey that NDP could come on top of conservative because their highest value in 35.9 is larger than 34.8. Okay, let's try the next guy. So our range for nanos is 34 to 40. 34 to 40%. Now the range for the other guy is 27.6. So let's use red. 27.6 all the way to 33.6. That's before for the 34, so there's no overlap here. So in that situation, no matter, I could be very confident that conservative in this survey is going to trump NDP, right? The conservative would win for sure there, because even if, because we're 95% confidence in these polls, so even if NDP does really well, that's still not as good as if the conservative did its worst. So with the one that there's no overlap is nanos research. And the last poll, if you look at 32.1 to 35.7, the high 33 is in between that range of 32.1 to 35.7. So in this case, since there's no overlap, we can say with 95% confidence that the percent of Canadian voters who will vote conservative is greater than the percent of Canadian voters who will vote NDP. So in which of the polls firms is there an overlap? Well, like Harris, in Angus, and in Ecos. And so in this case, there is no overlap. We can say with 95% confidence that the percent of Canadian voters who will vote conservative is greater than the percent of Canadian voters so we cannot say with 95% confidence that, and so in those surveys, we can't be confident that conservative will win over NDP. So in which of the polls can we say that with 95% confidence that the NDP will receive a higher percent of votes than the Liberal Party? So what we need to do is set up the same situation. We already know the range of values for NDP, so we need to do our range for Liberal. So we have to make a chart. So our Liberal voters, and we'll skip this last one, you'd have to do the exact same thing, make the chart. So Liberal, our Liberal intervals. So again, we have 4 different surveys. We have Harris Decima, we have Angus Reid, we have the Nanos research, and then we have the EGOS research. So those are the 4. So looking back at this chart, we're now looking at the Liberal. So for ignoring these 2 now, we're just going to look at the Liberal and the error and make our range value. So Liberals are here. So Liberals, so we have 22% minus 3.1 and 22% plus 3.1. So the first range is 18.9 to 25.1. 18.9 to 25.1. Then we have 19 plus or minus 2%, so 19 minus 2.2 and 19 plus 2.2, so 16.8 to 21.2. I believe that's what I said, yeah. The nanos, again, so 22.7%. minus our error of 3, and then 22.7 plus our error of 3. So it's going to be arranged 19.7 to 25.7. Yeah, and the last ecos, we have 21 plus or minus 1.8. So 21 minus 1.8, 21 plus 1.8. So between 19.2 and 22.8. 19.2% and 22.8%. Now just to review, we had our intervals for NDP. These are the Liberal intervals. NDP intervals, if you want to write them down again so they're right beside you, we had 26.9% to 33.1%. Is there going to be any overlap here? So looking at this, there's no overlap. So we can see this range does not come in contact with that other range. Then we have 30.8% to 35.2%. So again, okay, 16.8 to 21.2 and then 30 to 35, there's no overlap. The next one is 27.6% to 33.6%. And again, you'll notice there's no overlap. And the last range for the NDP is 19.2 to 22.8. Sorry, that was what we just had here. Up above was 29.4% to 33.0%. There you go. So again, 19 to 22 and then 29 to 33, there's no overlap. And so because all 4 of these surveys have no overlap, we can say with 95% certainty that NDP is going to beat the Liberals. So all polls suggest with 95% confidence, so there is that 5% chance, which is pretty small, that NDP will receive more Liberals weren't doing very good at that time. Will receive more votes than the Liberal Party. Okay? Now, if all the polls overlapped, then we can't be confident, right? That we can't really tell who would win in that situation. So let's skip that last question and move on and just kind of review some stuff. So the effect of sample size on confidence level. So really what we not, instead of just going through all of this, what's really just a quick review, our confidence level, right, is that 19 times over 20. So if in our sample we've measured the heights of more than half the students in the school, our level of confidence that the true mean lies within our interval would be well above 99%. Usually we can't sample 50%, more than 50% of our sample, especially if we want to sample like the whole world. I mean, have our population as a whole world. If our sample, we have measured the heights of about 1/4 of the students in the school, our level of confidence, the true mean lies within that interval, would still be very high, but not as high as if we can do over half. And so that's our confidence level. So basically, what we need to understand is, for a fixed margin of error, the confidence level will always decrease as the sample size increases. So basically, the more people you sample, the smaller, the more confident we are with our results. So the more people we sample or survey, the more confident we become, and the smaller error we're going to get. The more confident we are with our work, which makes sense, right? If you only sample a couple people, you're probably not really confident with those results. So let's look at a problem here. A company produces hockey pucks, and there's regulations that it has to be between 164 and 170 grams. The production equipment is set to produce pucks that have a mean mass of 167 grams and a standard deviation of 1.1 grams. Quality control testing is done on a regular basis to determine if the puck meets those requirement standards. To ensure that only a small number of pucks produced are rejected, the quality control manager must ensure that the mean mass lies between the range of 167 grams to 167.3 grams, 166.7 to 167.3. During each workday, a random sample of pucks is selected and weighed. The table below gives the sample size needed for different confidence levels. So notice, 89 pucks would make 99% confidence level, 73.98, 52.95, 36 is 90%. So state the confidence interval that the company is using for the quality control tests. So what is the interval that they're using? What interval? Confidence interval. The interval is between 166.7 grams to 167.3 grams. State the margin of error. So how do we figure out the margin of error if they give us the interval? Well, we know that there's that middle number, right? Plus or minus something. So how do we get this middle number if we're adding and subtracting the same thing? Well, it's pretty simple. We're going to subtract them and divide by 2. We're going to average them, and that gives us our middle. So to find the middle, 166.7, and we have 167.3. So the bigger minus the smaller. So let's average them to get that middle number. Oops. So subtract them, divide by, well, that's one way. Let's add them and divide by 2 to average them. Or, you know, it's 0.6 total distance. There's 2 ways to do this, sorry. One is we can find, if I know this whole distance is 0.6 between them, then their error is 0.3, because it's split between both of them. 0.3 plus or minus 0.3. Okay, so how could you get that middle number now? Well, 166.7 plus 0.3 would give me 167.0. 167.0. And if I add another 0.3, that gives me 167.3. You could have also found the middle number by averaging the two, which is adding them together, divide by 2. 166.7 plus 167.3, and then divide by 2. So that's your middle number is 167. And then you just need to figure out that distance in between. It really helps setting up when you're trying, if you know your range and you're looking for that middle number, is setting up that situation, right? So you know there's going to be a middle number that when we set up our interval, 167.3, and each time to get to it, we're adding and subtracting the same number. And so if that distance in between is a whole 0.6, then you must be adding and subtracting 0.3. And so 167 plus 0.3 gives you 167.0. Plus 0.3 again, 167.3. So there's our margin of error. So how many pucks should be weighed in each sample if the company wants to ensure that the mean mass is in the range of 167.7 grams, 167.3 grams, 49 out of 50? Well, the question is, what confidence level is this? Confidence level, 49 out of 50. Let's change that to a percent, because a confidence level tells us how much we should weigh, is 98%. So how many pucks? 98%, 73 pucks they should weigh. All right, so we're almost done to the next page. So D, pucks which do not satisfy the league regulation can be used in practice. How many pucks should be weighed if the company wants to ensure the mean mass is between these two values 9 times out of 10? So 9 times out of 10 is what confidence level? 9 divided by 10 is 90% if we change it to a percentage. So going back to our chart, 90% confidence is 36 pucks. That's simple. If the company were willing to accept a mean mass between 166.6 grams to 164 grams, would they need to test more or less pucks than in the table in order to attain the same confidence level? So now the old range used to be 166.7 to 167.3. Now they want to change it to be 166.6 to 167.4. So now we get a larger range. So if you're allowed more pucks within that, that means that you don't need to test as many. So they would need to test fewer pucks. A wider range of acceptable values reduces the number of values one needs to be equally confident. So a wider range reduces the number of values one needs to be equally confident. The wider the range, the less pucks you need to test. If it was a really small range, we're going to have to test more pucks to make sure that they land within that range. Okay, so use confidence intervals to interpret the following statement. A recent study showed that Canadian high school students spend an average of 1.5 hours per day accessing the internet, an average of 1.7 hours per day being physically active. 7.5. The results were considered accurate to put within 0.2 hours, 24 times out of 25. So let's interpret this. What's our certainty level? How confident are we in this work? So 24 out of 25 is equal to what? Let's find this as a percent. So times 100. 90 times 100 is 96%. So we can be confident with 96% certainty. So that's how we'd start off. So it can be said with 96% certainty Canadian high school students. Now let's figure out our ranges before we finish the rest of the statement. So first of all, our error was how much? Accurate within 0.2 hours. So that's our error. So internet was 1.5 hours plus or minus 0.2 hours. So what's our range going to be? So 1.5 minus 0.2 is 1.3 hours to add 0.2 is 1.7 hours. And our physically active is 1.75 hours. And again, the same error. So if we subtract 0.2, we're at 1.55 hours to 1.95 hours. So we are, with 96% certainty, Canadian high school students spend between 1.3 hours and 1.7 hours accessing the internet and 1.55 hours and so and between 1.55 hours and 1.95 hours being physically active each day. So you don't actually have to create this data, you just have to be able to interpret it. And so that would be it. Remember the interval would be, these are what we call the intervals, the confidence interval. This is what we call the confidence level. So you need to know these terms, which one's which, confidence level, and then our error, these guys, the plus or minus 2% is our margin of error. Okay, so just be able to, if I asked you what the interval is, you should be able to point that out. What's the confidence level? You should be able to point that out. Or what the margin of error is, point that out. And then also be able to interpret these polls. And that's the last lesson of statistics.